Hello everyone, welcome back to my channel. Now in this problem, we are going to solve it in two ways. One will be the lengthy way and second will be the short way, right? If you look at the problem, basically many times students are asking me that how to solve the problems which you are showing us in video. So basically whenever you see the video, the moment you see it, just pause it, right? And then try to solve the problem by yourself. Once you're done with it, then play it again and try to see the answer which is given below so that you can easily match your solution with respect to the solution which is given here. So this is the way, this is the only way we can do it, right? So let's go back to the problem. Now in this problem we are given the sec-butyl benzoate, right, which is the reactant. Now this reactant has undergone hydrolysis first, giving us G, and then there is a chain reaction following it. What do we need to do? We need to match the options given below with respect to the correct answer. So in the options, if you can see, it is asking us what is the compound P, the compound Q, and the molecule R. Basically, these are the reagents which are available here. We need to match them with the appropriate answers. So let's start. Now in the sec-butyl benzoate, basically secondary butyl benzoate is the molecule, this one, right? It is an ester molecule like this. This is the ester molecule of sec-butyl benzoate. At the first step, what is happening? It is undergoing the acidic hydrolysis. And we know esters undergoes hydrolysis to form alcohol as acid, right? To form alcohol and acid. So what will happen? It will undergo hydrolysis and it will form benzoic acid and a 2-degree alcohol, right? 2-degree alcohol, this one, 2-butanol. Now we have to check which one is G and which one is F. Now here it is saying the F1 is liberating CO2 with NaHCO3, and we know that carboxylic acids as well as benzoic acids, they have the tendency to liberate carbon dioxide when they react with NaHCO3, right? So this is our F1 and this is our G1. So if you write the reaction of F, this is our benzoic acid, it reacts with NaHCO3 to liberate and to form sodium benzoate and form H2CO3. And now we know whenever the acid formed, see H2CO3 is also an acid, and COH, that is PHCOH, benzoic acid, is also an acid. And whenever the acid formed on the product side, let's say this is acid A1, A2, this is acid A1. Whenever the acid formed on the product side is weaker as compared to the acid formed on the reactant side, right? Or if I can say, we can compare the pH value by, or we can compare the strength of acids based upon their pK value. Right here, pK of A1 is less than pK of A2. So that means what? That means H2CO3 is a weaker acid, and whenever H2CO3 is formed as a weaker acid, it easily dissociates to form H2O and CO2 gas. It liberates CO2 gas, right? So this is a little bit idea about the product H. So here the product H is what? Okay, we have to find it, right? So now this benzoic acid, what they have done, they have conducted the reaction of benzoic acid further. Let's do it. Now benzoic acid at first is made to react with ammonia along with the heating sign. We know benzoic acid reacts with ammonia to form benzamide, right? It forms PHC double bond O NH2. This is what we get. In second step, we are making the reaction of benzamide with NaOH and Br2 in the presence of Br2. Now this second reaction is basically what? It is Hofmann bromamide degradation reaction. And in Hofmann bromamide degradation reaction, what do? We remove, in a shortcut way, we usually remove that C double bond O from the original molecule, from the original reactant, and attach the remaining part with the remaining molecule. So what do we get here? We get aniline as the product, right? Next step is what? Next step is the reaction of aniline with NaNO2 plus HCl. So basically this is what? This is the diazotization reaction in the presence of at 0 degrees Celsius, right? So here what do we get? We get diazonium chloride salt. We get diazonium chloride salt. like this. And then when the disonium chloride salt is made to react with warm water, what will happen? The good living group N2 will be removed, and the product obtained here is the phenol, right? So phenol is obtained as the product, which is the H1. So here H molecule is this one, right? This is the first part of the reaction which we have done. So we have already identified G, F and H. Next step is we have to identify I, J, K, L. So now here comes the two ways. There are two ways. Either we start with the I and we use all the options here and keep on making the products till we go to the L, right? And then we compare with the correct answers or correct options. Or there is another method where we do the reverse engineering, right? Now, what is the meaning of reverse engineering? See, basically, in the last, the L product is the metamer of E, right? Now, E is this one, the reactant E, right? Sec butyl benzoate is E. We have drawn it here. This is E. And L is the metamer of E. That means L is also an ester. The compound formed L is also an ester. Now, to form the ester, what do we need? To form the ester, we need an acid, carboxylic acid, and alcohol, right? And if you look at here, from K to L, the formation of ester is taking place from K to L. That means K must be either an acid or alcohol. But here, a surprising factor is that the first molecule which is used here, that first this one is H, and H is what? H is phenol. That means we are using here phenol in the form of alcohol, right? We are using the phenol in the form of alcohol. That means the K compound is acid in nature. The compound K is acid in nature. I hope you are understanding. You are with me here to understand what I am trying to say. The K compound is acid, carboxylic acid, because we know carboxylic acid will react with phenol to turn into ester. Now, how it can be the metamer of E? Basically, what happens in the case of metamer, we know that around the polyvalent atom, the number of groups, the number of alkyl groups interchange their position. Now here, if you see, the phenol is reacting with acid. That means the metamer which will be formed, the ester which will be formed, will have the phenyl group on the alkyl part. Basically, the ester means what? Esters are written like this: alkyl, alkanoate, right? This is how we write the esters. And here the alkyl part comes where? The alkyl part comes with the single bond oxygen, right? This is the alkyl part. Here the alkyl part comes. Correct? So if we have to draw the metamer of E, what will happen? That phenyl group has to shift from C double bond O to the single bond O, because that is a requirement of product formation from K to L, right? So that means L product will be something like this: benzene with O, and here comes C double bond O, and then comes here C, like this. This is what L should be. This is what L should be, right? Now, if you look at here, this compound is totally the metamer of compound E, because we have interchanged the position of sec butyl and phenyl group along the C double bond O single bond O group. Along this group, we have what we have done. We have interchanged their positions, right? The position of phenyl group as well as sec butyl group. Now, to obtain the L compound, we are using the phenol, right? Phenol we are using, and the K should be acid. That means the compound K should be what? The compound K should be comprising this part. Just a second, let me draw it again. The L compound is here. This is the L compound which we have obtained, right? Like this. Now, if you do the hydrolysis of this one, let's say if I do the hydrolysis of L compound, what will I do? I will get phenol plus plus. This is the compound which we obtained, right? These are the two compounds which we have obtained. That means upon hydrolysis of the L compound, if we are getting phenol and this carboxylic acid, that means this is the acid which is formed in the option K. So the K compound is what? This acid. K compound is this one. This is our compound K, right? So slowly we are identifying the compounds. This is the compound K, right? In a way, see, I can do the problem in very quick way, but just to elaborate you and to give you the overall view, of how to solve the question. I'm just elaborating it and writing all the equations, right? So if you are fast enough, you can do the reactions in your mind also and quickly go to the options to correct them. Now the option K is what? This acid. Now the K is obtained from J, right? K is obtained from J, and the reagents, if you can see, used here are either CO2 and H plus, right? J to K, if you see, just a second. Yes, from J to K, if you go, we are getting K as acid, and J, the reagent used is R, and the reagent here are given as HCHO, 2 plus, and H3O plus, delta, CO2, H plus, H3O plus, delta. That means in case of option B and option D, if you see, in case of option B and option D, acidic hydrolysis is given, right? Acidic hydrolysis is given. And in the case of option A and C, if you see, an addition of extra carbon is done in the molecule, right? Now, if you look at the molecule here, where this one, in this L compound, in L compound, what do we have? In L compound, we have 4 carbons. There are 4 carbons, and the fifth one is C double bond O. Or we can say the final product, the K product which we have obtained. In K product, we have 5 carbons, right? 3 alkyl, 1, 2, 3, 4. 4 carbons this, and fifth one is this one, right? And if you look at the alcohol which is from G, where is G? Yes, the G alcohol which we have obtained. Yeah, this one. The G alcohol has only 4 carbon. That means from G to K, which we have to go. From G to K, if we have to go, we have to add one more carbon in this one, right? From G to K, if we have to go, we have to add one more carbon, and that carbon adding is been happening in this case. Either it will be in the case of option A or B or C or D, in all the cases, right? Now let's see. If you look at the K option in doing the reverse engineering, K is obtained from J and J is obtained from I, and J to K is basically hydrolysis in option B and D. Now we have to check which one is correct among B and D. We will go to A and C also. First we talk about B and D, because in B and D hydrolysis is done. Now before hydrolysis, if you see, I to J, what is happening? We are reacting with AgCN, DMF and NaCN, DMF. Now we know, on adding the NaCN to the molecule and then doing the hydrolysis of CN, we get COH, right? Hydrolysis of cyanide gives the COH. But on adding the AgCN, if we add AgCN molecule, let's say we have this molecule, let's say this is Cl plus AgCN. If we add the AgCN, then instead of getting, we get this molecule. Here addition takes place through nitrogen part. So we get the isocyanide molecule, not the cyanide molecule. But if we do the addition through NaCN by using NaCN, basically this is what? This is SN2 mechanism. So what do we get? We get here the CN, right? Cyanide molecule. And cyanide's hydrolysis, if we do its acidic hydrolysis, we get the carboxylic molecule, right? This is what is required. This is what we require. That means in this case, and this is how the addition of one extra carbon has taken place, right? That means here B option will not be correct, because we don't require the isocyanide, we require the cyanide, and whose hydrolysis will give you the COH. And it is also matching with regard to our environment, right? Because our requirement is what? Our requirement is to add the extra carbon in the G molecule, alcohol. So NaCN will undergo to give you the cyanide by SN2, and then its hydrolysis will give you the COH molecule, right? That means the G part, G alcohol, the G molecule alcohol, this one will react with HBr. That is what is given to us in the case of D option. P is HBr. When it reacts with HBr, what will happen? We will get bromide, and then this bromide will react with NaCN in the presence of DMF through SN2 mechanism. And what do we get? We get the cyanide molecule, and its hydrolysis, as if you mention match in the options, will get COH, carboxylic acid, like this, right? So this is how we obtain the correct option of ours. So the option D is the correct one. Now if you compare the option A, right, here also, if you look at P is SOCl2. So adding the SOCl2 to 2-degree alcohol will what will give you the, it is basically what, it is basically the Darzan's reaction, right? Addition of or reacting SOCl2 with alcohol gives the Darzan's reaction. Now this Darzan's reaction is the best way to react alcohol with SOCl2 to obtain alkyl chlorides, right? Are you remembering how? Because the byproducts formed here are SO2, right, and HCl. Both are found in the gaseous form, and they are liberated easily because they are gaseous products, byproducts, and we get the pure form of alkyl chloride. That means the I product here, if I use the option A, if I use the option A, the I product, let's do it again. We have this alcohol, this one. If we react with the SOCl2, we will get the chloride, right? 2-chlorobutane, secondary chloride. Now, next option is MgBr, Mg dry ether, Q option. If you make the reaction of this one with Mg and dry ether like this, what do we get? We will get the C minus MgBr like this, right? We will get the ether. And now if we do the reaction of ether with formaldehyde as it is given here, and then hydrolysis, what will happen? This negative charge will attack C double bond O, and the electron pair will go up, and we get here like this, CO minus H, and we have HO minus MgBr plus. And upon its hydrolysis, or in the presence of acidic medium, what do we get? We will not get the acid, but we will get only the alcohol, right? We will get alcohol. But this is not what is required in the option K. As the product K, or as the product K, we don't require this one, right? So that means option A is not correct. When it comes to option C, here also if you see, if I make the reaction of G with P option, PBr3, so G will be formed, G reacts with PBr3 to form alkyl bromide. Then alkyl bromide is made to react with what? Mg dry ether. That means if I do the reaction of alkyl bromide with MgBr or Mg ether, again we get what? We will get the Grignard reagent. Now this Grignard reagent is made to react with CO2 in the presence of, or we can say CO2 and then acidic medium. That means here if I do it reaction with CO2, so CO2 is electrophilic compound. CO2 has electrophilic nature, and Grignard reagent can act as nucleophile when there is no acidic hydrogen. So when we do the reaction of this one with CO2, the negative charge will attack carbon, making the electron pair shift to oxygen. So here it will form this molecule, and upon its acidic hydrolysis first, sorry, in the presence of acid H+, it will form the acid which is required for the reaction from K, right? K to, where is it? K to L, right? So yes, this is again the correct answer, correct acid which is required. That means we can go from G to K by using C also, right? So that means the options C and D are the correct answers for our question. I hope you understood the problem properly and you have done it. See, we have elaborated this problem in a very extensive way, but as I told you already, that if you are fast enough, you can do it in the mind also and quickly come back to the options to rectify yourself, right? Here it is given as extensive solution to you, so you can go back again to the video, watch it again, understand it again, and then finalize your concept. I hope you understood it properly. In the next session, we are going to discuss many more problems regarding the organic chemistry as well as physical chemistry. So stay tuned, keep watching, just like and subscribe your channel, keep spreading the love.